First thing we're going to look at tangent to normal in Cartesian form. We're going to look at it in parametric form, and we're going to look at the quarter contacts in there. Right, these are your equations. Okay, so the equation tangent xy equals c squared at the point, external point, is given by that. Okay, I'm not going to prove them today. Not enough proofs, how to implicit differentiate and all that sort of stuff. And then the equation normal, cos perpendicular to tangent, you use your perpendicular gradient and substitute your external point in and you get that equation there, x1 x take away y1 y is equal to x1 squared take away y1 squared. Right, so we need to find the equation of tangent and normal to hyperbola xy equals 6 at point 3, 2. That's the tangent. We're just going to substitute straight in the formula. So we've done maths examples of implicit differentiate, etc., etc. We'll go try and focus on some of the other questions we need to do today. The tangent, so it's going to be given by the external point 3, 2. So we've got y1, so 2x plus 3y is going to be 2c squared. Okay, so c squared in this example is 6. So 2 times 6 is cos 12. Actually, that does not look very good. Why isn't that consistent? 2c squared. y1 x1 y. No one getting there. Right. D dx of xy is d dx of 6. Alright, so the product rule, so second times derivative first. So the first is, of course, function of x. So y times the derivative of x, which is 1. And then, we've got to x dy. The first times the derivative second, we have to differentiate y. So we need to include dy dx is 0. So d dx of 6 is 0. Alright, so x dy dx is negative y, dy dx is negative y on x. So at the point P, which is 3, 2, dy dx is negative 2 over 3. Certainly not consistent with the formula, better double check them. Alright, so y take away y1 is equal to m x take away x1. And that's consistent, so y in that consistent with the formula. Bless you. Yep, you got it out of me too. Alright, so the perpendicular gradient is 3 over 2. The y take away 2 is going to be 3 over 2 over 2, and then we've got 4 over 2. Alright, so it's consistent with GeoGebra. Doesn't look consistent with my formula though, so we better double check them. Okay, so it's just another application of inputs, differentiation, finding gradient, substituting the line. Okay, question?